Great. So hello again. My name is Maxim Davgopoli. I'm a Meetup leader in Geneva, but here we are now starting the virtual Meetup, and we are covering the topics that quite far from AI, MCP, agent to agent, but still important, strictly connected and directly connected to the API economy. And the scope of this Meetup that's going to be presented by Artyom Subbotin, our integration architect, MuleSoft integration architect. So the scope of this meetup is about why API traffic insights matter, how to address security, compliance, and cost efficiency, how usage-based model affecting the scale and cost and business growth, and what KPI metrics we need to track for the business in this context. And Artyom, I'm passing you the word, and welcome.
Okay, thank you, Maxim, for the intro. Hello, everyone. Nice to meet you all here, and thank you for joining. Yes, as Maxim said, so that's a topic which we will go through a bit far from the modern topics, and which is right now well known, but still it's relevant for all of type of integrations, not only for the MuleSoft, and maybe it will be also like a high level understanding of the steps which should be done to protect revenue streams, again, not only for the MuleSoft. And let's start from the point why this matters. In today's digital economy, APIs are a backbone of business. They connect applications, data, and services across the enterprise, powering everything from customer experiences to internal operation. By exposing core businesses' capabilities in a reusable way, APIs enable speed, agility, and innovation, the very things that give organizations their competitive edge. But with this central role comes a stark reality. When APIs fail, business stops. So in the world where customers expect 24/7 access, any outage or slowdown translates immediately into loss of trust and loss of revenue. For example, a checkout API going down in an e-commerce platform, a payment API failing in a bank, or a booking API failing in a travel application, each of these means frustrated customers, abandoned transactions, and potential damage to the brand reputation. For digital leaders, of course, uptime is no longer just a technical concern. It's a business-critical KPI tied directly to growth, customer loyalty, and competitive differentiation. The key to protecting this digital backbone lies in early detection. Traditional approaches wait for things to break before acting, but by then, customers are already affected. With proactive monitoring, anomaly detection, and predictive insights, businesses can spot warning signs before they escalate into outages. APIs have transformed IT from a support function into a growth driver. But to truly deliver on their promise, organizations must ensure these APIs, their digital backbone, are reliable, secure, and proactively monitored. We already touched a topic about the outages and downtime, but what is the cost of API downtime? Today's digital world demands near-perfect uptime. Outages are no longer behind-the-scenes technical issues. They are highly visible failures with serious consequences. Data from sources like Down Detector, Gartner, or Ookla collectively show that the cost of downtime is rising, not just in dollars, but in customer trust, reputation, and operational resilience. You can see on the screen key insight, which is provided by Oklo, Down Detector, and Gartner, but under the hood, it's still hidden costs and risks, such as lost sales or transactions that cannot be recovered afterwards. Degradation of customer trust. Once trust is broken by an outage, it's hard and expensive to rebuild. Reputation damage amplified by social media, third-party monitoring, and so on. Compliance, regulatory, or contractual penalties in industry with strict SLAs or legal obligations. In other words, downtime is expensive, both in direct cost and indirect damage. Gartner, Down Detector, and again, Okla all point to the same imperative. Prevention is vastly cheaper than reaction. Ensuring API reliability is not optional. It's a fundamental to protecting revenue, brand, and customer trust. And when we are switching to the topic of the MuleSoft, MuleSoft can help us in this topic using three different main points. The first one, it's distributed tracing with managed flex gateway. So modern architectures are distributed. A single customer action might pass through dozens of APIs, microservices, and backend system. Traditional monitoring tool provide fragmented visibility, leaving teams scrambling when outages occur. MuleSoft's managed flex gateway introduces distributed tracing across all API calls. Each request carries a unique trace ID, allowing teams to follow its journey from entry points to backend system. This make it possible to identify performance bottleneck at the API, connector, database level, and so on. Correlate outages to specific hops and policies within seconds. Cut mean time to resolution, and apply consistent governance, security, and observability across hybrid and multi-cloud environments. The second important point here is usage-based pricing for scalable monitoring. One challenge with observability tools is cost. Capturing every metric and trace across all APIs can be very prohibitively expensive. MuleSoft addresses this through a usage-based pricing model that aligns monitoring speed with business value. This means enterprises can start with deep monitoring for their most critical APIs, like checkout flows, payment flows, expand coverage gradually, paying only for what they observe. Control costs through quotas, sampling, and retention policies, and map monitoring costs directly to API revenue or transaction volume. And the last but not least, it's a proactive detection to protect revenue streams. So the differences between prevention and reaction is measured in lost revenue and customer trust. MuleSoft's proactive detection capability ensure that anomalies are flagged before customer notice issue. Features which include like SLO and SLA-based alerts on latency, error rates, and saturation. Business-aware thresholds, integration with automated remediation workflows like rollbacks or traffic shifting, or prioritization of high-volume journeys such as payments or order status updates. So we will look through these three main points deeper, one by one. But in other words, in today's digital economy, API availability equals business continuity. MuleSoft's approach, like distributed tracing, scalable monitoring, and proactive detection, empowers organizations to minimize downtime, optimize monitoring spend, and safeguard customer experience. With downtime costing thousands per minute, MuleSoft provides the visibility, flexibility, and foresight needed to turn API reliability into a strategic advantage. And starting with the distributed tracing model, why it's so important. So the real shift with distributed tracing comes from changing the length of measurements. Evaluating system health through requests rather than isolated events. Metrics and logs are useful, but they are often subjective. Metrics can be interpreted in different ways depending on the perspective, person, and so on, while logs depend on how individual developers write them. So both tends to be fragmented, tied to parts of the system rather than the whole, which makes it difficult to see the bigger picture when making an architectural decisions. By following a request end-to-end, tracing provides visibility into how that request moves through the entire application ecosystem. This gives a far more accurate reflection of the end user experience than metrics or logs alone. Even though logs and metrics are still dominant observability, largely because they haven't been around longer, the industry has over-relied on them. Metrics provide breadth but lack the technical depth for root cause analysis, while logs offer depth but remain sealed and discounted. Tracing bridges this gap by combining the strategic insights of metrics with the technical precision of logs, delivering a holistic view that is richer, more actionable, and aligned with both operational and business's goals. And on the next screen, you can see the benefits of distributed tracing. So end-to-end visibility, you can track every request across APIs, microservices, and backends. It provides a single timeline of events showing latency, errors, and other dependencies. The next one, it's a faster troubleshooting. Again, as we already discussed, that it cuts mean time to resolution. It pinpoints exactly where fail occur, like API policy, it may be connector or backend system. The third one, it's improved governance and compliance. It's possible to enable tagging, for example, environments, headers, business context for tracing, ensures consistent policy enforcement in observable like authentication, rate limiting, or secure topic, and supports audit and compliance need with full traceability. The next one, it's performance optimization. It identifies bottlenecks, slowing transactions, highlights where capacity or caching maybe or scaling is needed, and allows optimization of high-value customer journeys, such as already discussed, checkout, payments flow, and so on. Of course, business value and revenue protection, like prevents outages that cost thousands of dollars per minute, detects anomalies before they impact customer, what is more important, and protects brand reputation, of course, customer trust and revenue continuity. And the last one, but not least, it works with different frameworks such as OpenTelemetry, for example, or Splunk, Azure Monitor, and so on, provide flexibility for enterprises with mixed observability stacks, and allows future-proof monitoring by aligning with open standards. So in general, distributed tracing transform opaque API networks into transparent, measurable journeys. It helps IT and business teams reduce downtime, improve performance, and safeguard revenue while ensuring compliance. And that's a general benefits of distributed tracing, but let's move forward and see in more details about the MuleSoft distributed tracing. Like we just discussed, traditional monitoring tools struggle to keep pace, often delivering fragmented data that slows down problem resolution. But Managed Flex Gateway addresses this through distributed tracing. Each request is tagged with a unique trace ID that follows it across every system, creating a complete end-to-end view of the API journey. This makes complex API landscapes transparent and measurable, giving IT and business team confidence that their APIs, the backbone of the digital business, are resilient, high performance, and revenue protecting. While many organizations still rely on log aggregation for sure for tracing, that approach is reactive with delays between when an event occurs and when it shows up on dashboard. And we will review the distributed tracing on the example of the Open Telemetry framework. It's one of the possible frameworks, and this framework delivers real-time tracing, allowing issues to be identified and resolved before they impact customer. The general architecture you can see on the screen. The tracing model can be grouped into two main areas, let's say like this. It's a client-side components and server-side components. Client-side components, it's a tracing SDK or client. It's embedded in the application or service. This library creates trace data or spans. It's another internal tracing terminology. And using APIs such as start, end, inject, extract, and so on. It records the flow of requests and interactions. The second point on the client side, the second component is agent. It's deployed close to the microservice with the performance efficiency. It receives spans from the client and forwards them to a central collector, usually something in near real time. Okay, and now we are on the server-side components, and the first one is collector. It acts as a high throughput processing layer. It aggregates spans from multiple agents, applies throttling or sampling if the database, for example, is overloaded, and ensures reliable delivery. The second one component is storage. It can be different NoSQL database, for example, or Elasticsearch framework. It's a database that persists trace data for querying and analysis. The next one, it's a query service. It retrieves trace data from storage and makes it available for analysis tools. And the last one, of course, it's user interface. So just to allow developers or maybe other persons to explore transactions end-to-end and identify performance bottlenecks. So for now, I will switch to the next slide. And on this slide, we will see what MuleSoft provides for distributed tracing, especially based on the Flex Gateway. So it will be a video. I hope everything will be okay with the sound.
Application networks are becoming increasingly complex. The expectation placed on IT operations is to keep everything running smoothly, even as additional technologies are continuously added to their infrastructure stacks. And when those stacks break, you need to be able to recognize, investigate, and quickly react to any operational issues. A strategic approach to creating resilient infrastructure is critical in delivering for internal stakeholders and customers alike. And that's why MuleSoft is excited to announce the launch of 3 key innovations for endpoint monitoring. Anypoint Insights lets you examine your application network subset via different logical entities. Distributed tracing is the ability to append a trace to track a request through your application network to get a holistic understanding of your stack health. And Telemetry Exporter, the ability to export real-time telemetry data to your observability ecosystem, like Datadog, Splunk, and Dynatrace, built on the OpenTelemetry standard. Let's take a look at Anypoint monitoring. This is the Anypoint Insights dashboard. You can drill into the health status of various entities across your Mule ecosystem and search across business groups and environments to identify entities that are impacting performance. Next, let's head over to traces. With the launch of distributed tracing, Anypoint users can now see a collection of request traces that have been processed through their application network. You can drill into specific traces to start evaluating where performance bottlenecks may be situated. It's simple to configure this telemetry data for export. Just navigate to our Telemetry Exporter tool and progress through the setup wizard.
Okay, and now I just wanted to reshare my screen with another page. So I hope everyone can see the page from the MuleSoft documentation. Today we will not go through the practical part of demo because distributed tracing for Flex Gateway is available only for managed Flex Gateway, and managed Flex Gateway it's not included as a part of the trial Cloud Hub account. Moreover, it's possible to set up the tracing inside Flex Gateway, but then it will be not possible to see any telemetry data because you can export telemetry data only for the licenses with premium subscription. But still, I would like to go through the documents a bit. So the main purpose of the distributed tracing, or the main configuration parts, still stored on the registration file of the Flex Gateway. If you are familiar with the Flex Gateway, you will see that it's just an additional part with the tracing. Here we can add the generic information about the tracing which we would like to add for the gateway on the high level. Then, if you would like to modify tracing per API, then we need to include tracing policy for each API. Again, it will be happened in the configuration file called registration.yaml for the Flex Gateway. Of course, it different depends on the deployment model, but in general, for the local mode, for the connected mode of the Flex Gateway, it's pretty the same. And just another page from the MuleSoft documentation, which will show to you that it's possible to export telemetry data to any third-party monitoring systems such as Splunk, Elasticsearch. Of course, it's also possible. But you see this node, it's only for the titanium tires, and it's not possible to do within trial account for Cloud Hub. But in general, the configuration looks pretty straightforward because this telemetry exporter already will be included to your license or package, and then it will be done in the several clicks. I mean, you can configure, if you already have third-party systems like a Splunk or Elasticsearch, it can be quickly and easily configured using the Cloud Hub UI interface. But unfortunately, we couldn't demonstrate right now. Okay, going back to our current topic. I hope everyone can see the presentation back, right? I hope it's okay. So we are talking about the different frameworks and distributed tracing. And for some of us, it can be complicated to understand why we need to implement such difficult solutions like OpenTelemetry. What is the purpose? Why we could just use ELK stack for this one? And this question is pretty reasonable because OpenTelemetry and ELK stack both offer robust observability solutions, but they excel in different areas. OpenTelemetry is designed for distributed tracing and metrics collection, while Elasticsearch is primarily focused on a centralized log management and analysis. You can see on the screen key differences between these two frameworks. And of course, it's not like 100% cases where OpenTelemetry or ELK should be used. It's necessary to review a particular case and decide what will be the best solution for this. But OpenTelemetry in general is a great choice if you need distributed tracing to debug microservices. You want a unified solution for logs, metrics, and traces. For example, if you are working with Kubernetes or cloud-native environment. The same situation for ELK stack. If you would like just primarily log aggregation and analysis, or you want out-of-the-box search and visualization capability, ELK will be the best one here. So again, it depends on the project case where you need to implement extended logging or distributed tracing. Okay, and on this step, we are finalizing the first points from the list of our important steps where MuleSoft can rescue us. The next one will be about usage-based pricing. We will not discuss here packages, prices. We will go through the general understanding what is usage-based pricing and how this usage-based pricing can help us in our particular case. So in integration, there are three primary pricing drivers. It's a mule flow, mule message, and data throughput. Of these, flows and messages are the main levers that define consumption. This represents a shift from the old core-based model that some customers still used. About 3 years ago, a new model was released where we are moving away from selling cores to focusing on flows, messages, and throughput as more accurate measures of value. Flows sometimes can confuse us because the term itself is used in many contexts. For example, RPA flow or composer flow. And it's important to clarify that in this model, we are specifically referring to the mule flow. Messages represent the payloads that pass through those flows, while throughput measures the overall volume of data moving in and out of the system. In another way, in automation, usage is measured more simply with a single fungible token that can be applied across different automation needs in API management, consumption is similarly tied to a single metric that primarily defines usage and drives costs. We identified three main integration drivers, and it called integration metrics. So again, MuleFlow it's a flow which represents a collection of logical operations triggered by an event source. It counts toward customer entitlements only when it's actively deployed and running. Mule flows essentially represent the breadth of the customer's integration landscape, the number of systems and processes connected. Mule message, it's a message is the data payload processed through one or more Mule flows. Messages measure the intensity or volume of usage and indicate how heavily integrations are being utilized. And the last one, data through output. This is the total amount of data transferred in and out of a Mule application, again, measured in network bytes. It reflects the scale of traffic moving through the system. Honestly, for me, it was pretty difficult to understand the main differences and the purpose of this. And I heard a very useful analogy how it can be compared to the household electricity usage. So the number of appliances, it's a Mule flow, like how many processes are running. The wattage consumed by each appliance, it's a Mule message, how much work is being done. And the total power coming into the home, it's a data throughput, like the overall volume of consumption. Of course, like we can ask a reasonable question, like what is the benefits? Is it really useful? And I can answer yes and no. Like the benefits of the usage-based pricing model, it's the first one, it's agile cost structure. Investments scale with demand, supporting growth without unnecessary financial commitments. Improved cost efficiency, like lower fixed overheads and streamlined operations deliver stronger long-term returns. The next one is accessible entry point. Affordable pricing lowers the hurdle for launching new initiatives and entering new markets, for example. And the last one, it's direct value alignment, like costs track alongside business impact, like making ROI transparent and easier to justify. But at the same time, you should understand the possible risks. It's a potential difficulty in cost prediction. You need to optimize deployments to avoid waste. And of course, you should constant monitoring of consumption metrics, because depends on this, on consumption, you will get the price. So, okay, we gone through the second main point. It's a usage-based pricing, and the last one, it's not so pure understandable, but really requires a deep analysis. So from detection to protection. APIs run everything from checkout flows to payment gateways, as we already understand. So when one call slows down or fails, the impact can ripple across systems and customers. Traditional monitoring tells you that something is broken, you can get it from the logs, but rarely it says you where and why. This gap delays fixes and puts revenue at risk. At the same moment, distributed tracing closes the loop. It's not only about the MuleSoft distributed tracing within managed Flex Gateway, but in general about the distributed tracing. So, for example, every request in distributed tracing gets a trace ID that follows it across APIs, policies, and backend system if it exists. Each hop produces a span. It's complete with timing and error details, so teams can see the entire transaction end to end. But detection alone isn't enough. What matters is catching anomalies early enough to act before customer notice. And distributed tracing makes this possible. When error rates spike or latency climbs, tracing provides not just an alert, but context, which API or maybe connector or backend system or database is not responsible. That context means operations team can move straight to the root cause instead of wasting time in analysis. The result is faster remediation and dramatically lower mean time to resolution. For example, a checkout flow spans the mobile application. Then if we're talking about the MuleSoft, the transaction going through the experience layer, process layer, system layer, and then go to the payment system. And suddenly error rates increase. Tracing shows the problem that it's not in the orchestration logic, but in the incorrect configuration of the payment connector. And at this time, the team can quickly revert the changes or implement a very urgent fix within minutes, and customer never notice. But if we're using the distributed tracing, using the traditional login, it will spend lots of time while you get the first alerts of the appeared issue. The technical benefit of distributed tracing translates directly into business value. Each avoided outage protects transactions and revenue that would otherwise be lost. Each rapid fix preserves customer trust and keeps brand reputation intact. Over time, this proactive approach reduces compliance risks, saves operational costs, and strengthens business continuity. The next slides again will demonstrate the general understanding of the best practices. Of course, with the small piece of the MuleSoft, but from the other hand, it can be applied to the whole understanding of integration and how it can be done. So integrate monitoring into everyday development. So do not bolt an observability at the end. Build it into your release process so that every new API or update comes with monitoring enabled. This ensures that when a change is deployed, you can see how it behaves right away and fix problem before they reach customer. The second suggestion is connect technical metrics with business goals. So latency and error rates are important, but they don't tell you the whole story. Link your monitoring to businesses outcomes like checkout success rate, payment authorization, or customer logins. This way, an alert isn't just something broke, but sales are at risk. The third one is automate alerts and escalation. In this case, speed matters, really matters. Automated alerts that go to the right team with clear context reduce confusion and wasted time. Even better, link alerts to runbooks, for example, or automatic responses like rolling back or this faulty release, so the issue are resolved within minutes instead of hours. And the last one, but not least, test your readiness regularly. Like, don't wait a real outage to find out if your team is ready for such kind of cases or not. Run regular fire drills to test detection, communication, and resolution. These exercises build confidence and ensure that when a real issue arises, everyone knows what to do. By following these practices, organization move from reacting to outages to preventing them, what is the most important point. And okay, we are almost at the end, and we need to speak about the key takeaways, like API outages equals to the revenue loss, because every minute of downtime translate into lost sales, frustrated customers, and brand damage. Distributed tracing in Flex Gateway, but not only in the Flex Gateway, but in general, it's a deep visibility. End-to-end tracing uncovers where issues occur, reducing resolution time and improving reliability. Usage-based pricing, it can be cost-effective scalability, like monitor what matters most, scale coverage as APIs grow, and align cost with business value. And of course, proactive detection ensures business continuity, like spot anomalies before customers are impacted, protecting revenue streams and customer trust. Okay, what's I would like to add in conclusion? This topic is really more in theory, but I hope I bring to you the understanding that distributed tracing, or maybe in some cases extended monitoring, can really help and firstly avoid serious problems and potentially save the money. And to do this, please review 4 points which are on the screen. The first one is start enabling distributed tracing on your APIs today. Don't wait for the next outage to expose blind spots. Activate distributed tracing, it's no matter MuleSoft or not, to capture every request from entry point to backend system. This will give your teams the visibility they need to identify bottlenecks, reduce downtime, and safeguard customer experience. Evaluate your current monitoring strategy against business impact. Like, ask a question: are you only detecting issues after customer complaint, or like do your alerts tie to business KPIs like sales conversations, payment success rates, or user logins? Align monitoring with measurable outcomes, ensure IT is directly protecting revenue and brand reputation. Explore MuleSoft usage-based pricing to optimize ROI. Like, monitoring everything everywhere can become costly and unsustainable, of course. MuleSoft is flexible. Usage-based pricing model lets you focus observability on your most critical APIs first, then scale coverage as your digital footprint grows. You only pay for what you monitor, so your investment grows in lockstep with the business value. And the last one, like, make proactive protection a business discipline. Treat resilience as more than a technical requirement. Run regular incident drills, automate responses workflows, and embed observability into your CI/CD flow if it exists. And just a last note that the next outage is not a question of it. It's a question of when. The organization that thrives are those that prepare. Start building resilience now with the distributed tracing, especially with the MuleSoft distributed tracing, smart monitoring, and proactive protection. So that's pretty much it on my end. Thank you for your attention, and I will be glad to answer your question if they exist.
Yeah, thank you very much for the presentation. I raised the hand, I believe, the first one. And can we go back to the previous slide with call to action or call to action? At the first part of the presentation, you said that some of the observability and traceability options are available only on Titanium subscription, under Titanium subscription. And but we know that most of the clients under Platinum subscription, right? And your call to action, they're still valid for the clients under Platinum subscription. You need to consider switching the subscription option, or any other things should be done on the client side. Thank you.
Yes, that's a very good point. But firstly, we are talking about the distributed tracing in general. So within the MuleSoft, right, it's available under the Titanium subscription. But in this case, for example, Elasticsearch stack will be much better than simple any-point monitoring, which is built in for the all subscriptions, because it's not a real time. Like we go through the advantages of the distributed tracing, and even Elasticsearch stack will be much better than simple monitoring, Cloud Hub logs, and so on. So in this case, I'm suggesting to use third-party systems like Splunk, ELK, to aggregate logs, to see the metrics, and to proactively react on the apparent issues. But of course, distributed tracing using the MuleSoft, especially Flex Gateway, it opens to you a big functionality inside the Cloud Hub platform. So in this case, you will not do any additional steps for configuration, ELK, or something like this. Everything is built in. You will just press on the several buttons and configure the distributed tracing inside Cloud platform. So I hope I answered your question, Maxim.
Yeah, thank you. And just another point, that's, if I understood you correctly, your presentation, that's switching or becoming user-based customer, the monitoring becoming more and more important in terms of API economy, correct?
Yes, of course. But like we know, it's not the secret that there is no any possibility to choose between the pricing models, as far as I know. And for now, it's a good opportunity to think about optimization on the integration side, at least. But of course, it can bring new risks. We go through it, we discuss it. But from my understanding, it's really a good point to think about reusability and rework of the existing implementation, like, for example, deleting some duplicates and so on.
Yep. Thank you. And a couple of comments in the chat. Amrit is texting for the next time. Can you do a demo on tracing with managed Flex Gateway? Amrit, let me tell you that a couple of meetups ago, Artem already conducted the Flex Gateway related meetup and presentation. I don't remember if we covered here the tracing. But yeah, good point. The next comment from Siko, sorry if I'm not pronouncing correctly. Do someone know when distributed tracing will be available for managed Flex Gateway? And Amrit answered the Titanium subscription is only needed for exporting telemetry data. Let me tell you from the own experience with Titanium subscription for one of our clients, we considered the Titanium subscription, and the First of all, based on my understanding, based on my experience, the difference in the support level. So support level on Titanium subscription is much, much higher. So if your client is like from working for really critical strategic organizations like, I don't know, nuclear station, nuclear plant, where it's important to always to be available, all the integration, that makes sense. Of course, because the up-down time for 3 nines, 99.99 under Titanium subscription, under Platinum subscription 3 nines, 99.9. And many other things that you're getting under Titanium subscription in terms of support. But also, as we see from presentation, on this presentation from Artyom, in terms of monitoring and traceability, and etc., what makes sense, of course.
Yes, and unfortunately, this feature is not available as we just saw in the trial account. Moreover, distributed tracing available not on the self-managed Flex Gateway, but on the managed Flex Gateway. And managed Flex Gateway is also a feature which is not available under the trial account inside Cloud Hub. So we will think about the solution, how we can avoid this limitation, and most probably potentially in future can prepare another meetup showing how it's work.
Sure. We have another couple of minutes to the end of the meetup. Any questions, any comments? Great. Let me then stop the recording.